Using frequency distributions to create probability models. After watching this video, you will be able to translate the phrases at most and at least into inequalities, answer questions about a given probability model, calculate the relative frequency from a frequency distribution, and use Microsoft Excel to create a relative frequency table from a frequency distribution. This video assumes an understanding of basic probability. For a lesson on basic probability, please watch the video entitled Basic Probability. Inequality vocabulary. The inequality symbols that are commonly used in mathematics are less than, greater than, less than or equal to, and greater than or equal to. This chart shows you a collection of phrases that represent different equalities and inequalities. The two phrases that we are most interested in this video are at most and at least. Notice that at most means less than or equal to, and at least means greater than or equal to. How can we remember this? Example 1. A sign on a children's ride says you can be at most 4 feet tall to ride the ride. You are a parent who is 5 feet 5 inches tall and you want to ride the ride with your child. Will they let you on the ride? Pause the video, write down your answer, and then unpause it to see if you are correct. The answer is no. Your height is more than 4 feet tall. In order to ride the ride, you have to be 4 feet or shorter. In other words, the height of the person on the ride must be less than or equal to 4 feet. Example 2. A child who is 4 feet 10 inches tall wants to ride a roller coaster. The sign on the ride says you must be at least 5 feet tall to ride the ride. Will the attendant let you ride? The answer is no, you are not tall enough. In order to ride the ride, you have to be 5 feet tall or taller. In other words, the height of the person on the ride must be greater than or equal to 5 feet. Can you think of other everyday real-life examples of using the phrases at most or at least? The more examples you can think of, the easier it will be for you to recall their meaning on a test. Pause this video, write down your answers, and then unpause it to see the examples that are supplied here. One example is voting. In the United States, you have to be at least 18 years old to vote in elections. That means your age must be greater than or equal to 18 years old. If a t-shirt costs $10, you must have at least this amount of money to pay for it. You could have more than $10, but if you have less than $10, you cannot afford the shirt. Therefore, the amount of money you have must be greater than or equal to $10. You tell a child that he or she can have at most 2 cookies for dessert. The child could have no cookies, 1 cookie, or 2 cookies, but he or she is not allowed to have more than that. Therefore, the number of cookies must be less than or equal to 2. A guideline says that extra credit for a course can account for at most 1% of the overall course grade. That means that extra credit cannot account for more than 1% of the course grade. In other words, extra credit must be less than or equal to 1%. Example 1, using a probability model. The following table shows income distributions of households in the United States in 2013. It was taken from Sullivan's 5th edition textbook. Use the frequency distribution provided to compute the probability that a randomly selected household earned the following incomes in 2013. A, $200,000 or more, B, at least $10,000, and C, at most $15,000. Let's begin with part A. The frequency distribution tells us that 5,913,000 households earn $200,000 or more. But 5,913,000 is a count. It is not a probability. How can we find what proportion of households earn this amount of money? To determine the proportion of households who earn $200,000 or more, we must divide the number of households in that income bracket by the total number of households represented in this distribution. That means we have to add all the values in the second column. When we do this, we find out that the total is 122,953 households. Note that this word thousand is here because all of these values here are given in units of thousands. So again, according to the table, 5,913,000 households earned $200,000 or more, out of a total of 122,953,000. So we put those two numbers over each other and divide, and we find out that approximately 0.05 or 5% of the population earns this annual income. Let's move on to part B. This is asking us for the probability that a randomly selected household earns at least $10,000. So we need to figure out which of these numbers over here, or which of these brackets represent at least $10,000. Pause the video and see if you can figure it out. Remember, at least means greater than or equal to. All of these represent salaries or incomes that are $10,000 or more. That is a lot of numbers that we would have to add up in order to calculate the probability. Can you think of another way to find the probability of earning at least $10,000 using a rule we learned in a previous video? We can use the complement rule. This is the complement rule right here. It says the probability of an event not occurring is equal to 1 minus the probability of the event occurring. So we can use the complement, which is the people who earn less than $10,000, which is just a single number, to find the probability of the complement of that event. So the probability of earning at least $10,000 is 1 minus the probability of earning less than $10,000. So we have 8,940 divided by the total number of people represented in this table, and that's about 7% or 0.07. Plugging that into our equation, we find out that about 0.93 or 93% of households earned at least $10,000. Notice that by using the complement rule, we saved a lot of time and possible error because we didn't have to add all of these values. Example 1C. Use the frequency distribution provided to compute the probability that a randomly selected household earned at most $14,999. First, we have to figure out which brackets in the table represent at most $14,999. Pause the video and see if you can do this, and then unpause the video to see if you are correct. Remember, at least means greater than or equal to. If you said the first two rows in the table, then you were correct. First, we can add the two numbers together. We add 8,940 to 6,693 to get 15,633. Remember, this number, this 15,000 number, is a count, not a proportion. We still have to divide by the total number of households represented in the table. Doing that, we find that about 13% of the households earn at most $14,999. Example 1, an alternative approach. Instead of calculating each probability individually, we could have started the problem by creating a relative frequency distribution. You can see one here. First, we take each number and we divide it by the total. Then this fraction becomes a decimal. Notice we're rounding all decimals to the nearest 100th. It's always a good idea to add up all of these decimals and make sure that your sum is 1, just in case you made some sort of typing or math error. At this point, you might be thinking that this is a lot of calculation and the probability of error is very high. So what I want to take a minute to show you is how to use Microsoft Excel to do some of these calculations. So let's navigate over to Excel and I will show you how to do this quickly and easily. Let's begin. As you can see, I have already entered the raw data from the table into Microsoft Excel. There's not really any way to do your calculations without first doing this. Now, if you think about it, data entry is one of the sources of error. It's very easy to either transpose numbers or mistype something. So when you're doing any kind of data entry in this course, and you will throughout the semester, always double and triple check the numbers that you've typed to make sure that they are correct. So the first thing we need to do in Excel is we need to add all of these numbers together. This is super easy. All you have to do is click on a cell and you're going to hold down the left mouse button and drag to select all of these cells. Then once you're done, you can lift up the mouse button, and then it will be selected. So we're going to go over here. Notice that I'm in the Home tab. So I have the Home menu. And if I go over here to the right, I'm going to click on Auto Sum. So just click on that once. And all of a sudden, notice that the total is, it appears. Okay. So if you think about the pros and cons of doing this on a calculator versus Excel, we had to add all of these numbers up anyhow, manually, either typing them into a calculator or typing them into Excel. If you put them into Excel, then the advantage is that you can do some of the other steps much more quickly. So let's see how we can go from here to creating the proportion or finding the relative frequency. Okay. So let's just call this relative frequency right here. Okay. So the first thing I want to do is I'm going to type equals. Notice the equal sign appears here. And what that does is that tells Microsoft Excel is that I'm about to give it an equation. Okay. So I hit equal sign and then I come over here and I select the cell. Notice the number or the letter number B2 appears. Okay. So then I'm going to come up here. I'm going to hit the /, which is really a division symbol. And then what do we want to divide B2 by? Well, we want to divide it by this number right here, B12. So then I press enter. Okay. Now the next step is a little bit weird, but you got to trust me here. So I'm going to click on put the cursor right in front of the B, and I'm going to type in a $sign before the B and the 12. And what that does is it freezes that cell location, so that as I click and drag, which I'm about to do, it does not change the location of that cell. Okay, so I'm going to click here. Notice that my cursor turns into a small black crosshair instead of the big white one. So as soon as you see that change, I'm going to click down and hold with my mouse. Okay, and holding down that left mouse button, I'm going to drag this all the way down. Okay, so at this point, okay, when you're doing this, your results are going to look like this. They're going to have a lot of digits after the decimal point. And we don't want that, right? We want only 2 digits. So of course you could go through the trouble of rounding, but let's be lazy together. We're going to right click with our mouse and we're going to click on Format Cells. Okay, so if you're on the first tab that says number, we're going to go down to the second option, which says number. And automatically it's going to suggest that we use 2 decimal places, and that just happens to be what we want right now. So we're going to click OK. And notice all of these, all of a sudden, are now decimals. So let's say that instead of a decimal, I wanted a percent. I could either create a second column, or if I want to make this column into percents, once again, I could right click. I could do Format Cells, and I could click on percentage. Now this time, if I want a whole percent, I don't want these other decimal places here, so I'm going to type in 0 and click OK. And now notice all of these are displayed as a percent. And again, if I want to make sure that I didn't mistype anything, that everything really adds up to 100%, I can once again select and highlight these cells. I can click on Auto Sum, and lo and behold, it does add up to 1, or if I change that to a percentage, it adds up to 100%. Having watched this video, you should now be able to translate the phrases at most and at least to inequalities, answer questions about a given probability model, calculate the relative frequency from a frequency distribution, and use Microsoft Excel to create a relative frequency table from a frequency distribution.